To incorporate a qualitative predictor into a regression model, we need to find a way to transform them from categorical, which is the levels that they have are basically categories, into numeric values. The numeric values are needed in order to be plugged into the regression equation. And for instance, for example, if we have variable x1 be, let's say, the rating, then we need to find a way to encode these levels for rating into the regression model. And there are many ways to do that. We call that encoding categorical variables. There are different types of encoding that work best for different types of models. For regression, we are going to use a method that is called dummy variable encoding. Dummy variable encoding is basically uses what we call dummy variables, which are binary variables that can take only the values of 0 and 1 to be able to bring a categorical variable into a regression equation. So let me just repeat that. A variable x1, which is a binary variable, is a dummy variable if the values that it has are 0 and 1. Generally, 0 means the absence of something, and 1 means the presence of something. So the variable xy, binary, 2 levels, and the values that it can take are only 0 and 1. So we generally refer to a variable like x1 to be a dummy variable. Okay, so how can we transform a variable that looks like these, let's say having different ratings, to be a dummy variable? Well, actually, it's not going to work in that way to transfer a variable that has 5 different levels to be just one dummy variable. In turn, we have to create many of them. Okay, so let's make an example that is the simplest one. Let's suppose that we have the variable status, and that is actually a binary variable with 2 levels, and those levels are single and married. The first thing that we need to do in order to create dummy variable encoding for a variable like this is choose a base. A base level is going to be the level that we compare to, is going to be the level that we leave out, and that'll make a lot more sense as we go along. But the most important thing to recognize right now is that first of all, that base level is chosen arbitrarily. So we can choose the level to be single, or we can choose the base level to be married. For now, let's choose these to be single. Okay, and we are going to call these the base level. And the base level is going to be just that level that we compare against. Okay, so the next step is that we create dummy variables for each of the levels that are not chosen as the base. In this case, we just have one level left, which is married. Okay, so let's say that we create a dummy variable for the level married, and we're going to call it, remember, a dummy variable can only take the values 1 and 0. And we're going to say x is equal to 1 if equal to that level, married. And generally, the 0 will be everything else. If we have only just a binary variable like status, it will have to be single. It can't be anything else. It can't be something other than single. But in the case that we have more than one level left, then it will be anything other than married. So in this case, let's say for now, not married. Okay. All right. So just going back and reviewing, if we have a variable status, which is binary, taking two values, single and married, the first step is to choose a base level. Once we choose the base level, then we create dummy variables for each of the levels left that are not the base level. In this case, we have one, and we name that dummy variable to be x. This is going to be named something else generally, but for now let's just say that this is called just x. Okay. Again, it's going to have the values of 1 to be married and 0 to be not married. Now the model becomes, let's say y is equal to beta 0 plus beta 1 times x plus the error term. Okay, the expected value of this regression equation is just going to be the deterministic part. Remember that we assume that the expected value of epsilon, which is the error term, is going to be 0. So let's just give an example. Let's suppose for now that our y variable is, let's say, salary. And we are using the status variable as a predictor. And as such, in order to be able to incorporate it into the regression model, we can't use the variable as is, because we can't really multiply something by single or married. We have to encode it into numeric value. Using dummy variable encoding, we just select the base level and then create dummy variables for the rest of the classes. In this case, is x is equal to 1 if married, and x is equal to 0 if not. Okay, so how are we going to incorporate, let's say, a prediction for a married individual? And how are we going to incorporate it for an individual that is single? So let's start with the base level, okay, the base class. Suppose a person, the individual we're trying to predict the salary for is single. The equation will become just that. Y is equal to beta 0 plus beta 1 times x plus epsilon. Now, we know that if the individual is single, the x variable will be equal to 0. So this actually will become beta 0 plus, well, if you multiply beta 1 times 0, that term goes away. So we are left with y is equal to beta 0. So in other words, the expected value of y in that case is going to be beta 0. So beta 0 actually is going to be the mean for the base level. In other words, the average salary for a person or for an individual that is single. What we're trying to say here is now the beta 0, the y-intercept, becomes the prediction for the base level. Okay. All right. So now let's take and think about what happens when we are trying to predict somebody who is married. So let's take this out and let's put the 0 back here. All right. So we have now somebody who is married. The equation is going to be exactly the same: beta 0 plus beta 1 times x plus epsilon. But now choosing somebody who is married will set the value of the dummy variable to 1. So this will actually become beta 0 plus, well, beta 1 times 1 is just beta 1 plus epsilon. So the expected value of y is going to be just beta 0 plus beta 1. So in other words, beta 1 is just the difference between somebody who is single, and this would be the extra either negative or positive. This beta 1 parameter can be positive or negative, so it will be actually the actual difference on the average salary. Okay, so beta 1 is the difference for somebody who is married to somebody who is single, the average difference on the salary. Remember, beta 1 can actually be a positive value, meaning it would add to the average salary, or it can be negative, which would subtract to the average salary. But again, it is important that we recognize that because the base level goes to the y-intercept, we are always going to be comparing against that level, that base level. So it's really important that we understand that the base level is going to have a significance in everything that we do. All right, so we are going to take a look now at the next dummy variable encoding, and let's do an example that actually contains more than one level. So suppose that we have a 3-level variable. A variable contains 3 levels, and let's make a quick example. Let's say that we are looking at the variable measure, and we only have, let's suppose for now we only have just a few levels. So let's say we have marketing. Let's say we have an option of accounting and ISA. So those are the 3 levels that we have. Now, the first, again, in any case, we need to set as the first option, we need to set just what is the base level. Do we want to compare against everything, let's say salary against marketing students? Do we want to compare against accounting students? Do we want to compare against ISA students? And that, like I said, is going to be arbitrarily. Generally, this is going to be selected as the level that makes the most sense to compare to. Okay, so let's for now let's just choose the first option. In that, let's say that we set the base level to be marketing. Now, next step is going to be creating a dummy variable for each of the levels that are not the base. Okay, so in this case, we're going to create, let's say, a variable x1 for the level accounting, and it's going to be equal to 1 if the individual or the student or has an accounting major, and it's going to have a 0 value if not. Okay, remember, we're just wanting anything else other than accounting. Then we created the dummy variable for accounting. Now we need a dummy variable for ISA. Anyway, let's call it x2. It's going to be equal to 1 if the individual has an ISA major and 0 if not. Okay, so now the model becomes, well, let's say y again is salary. Y is equal to beta 0 plus beta 1 times x1 plus beta 2 times x2 plus the error term. And the expectation is just going to be the deterministic part. So wait a second. So how can we now predict the salary of somebody who, doesn't have an accounting major and doesn't have an ISA major because the variable is not in there? Well, those will be equal to 0. Both x1 and x2 will be equal to 0, and now we are at the base level. Okay, so let's go and try to do this here. So for instance, for let's say we want to predict a marketing, an individual with a marketing degree. So the equation will become y is equal to beta 0. Well, beta 1 times x1, but x1 in this case is going to be 0 because the individual is not an accounting major. So that term, beta 1 times x1, goes away. The same thing happens for x2. The individual is not an ISA major. So actually the model is going to be beta 0 plus epsilon. And the expected value of y is going to be only beta 0. So that would be the average salary for somebody who has a major of marketing. Okay, so let's go, let's say, for accounting. Well, we do the same thing. Y is equal to now beta 0 plus, well, beta 1 times x1. Now x1 is going to be equal to 1. So we'll have just this. Plus epsilon, the expected value, which will be beta 0 plus beta 1. This would be the average salary for somebody who has a major of accounting. It will be whatever the difference between the marketing major, beta 0, the average of the marketing major, beta 0, and then we put an extra term, beta 1, which will be the difference. If beta 1 is positive, then on average, accounting majors will earn more than marketing majors, which is the class that was left out, the base level. If beta 1 is negative, then on average, accounting majors will earn less than the base level. So, but we always have to compare against the base level. Finally, for ISA, we have I'll just write the expected value here. It will be beta 0 plus beta 2, which will be the difference between the average salary of marketing individuals with marketing degrees to ISA students. So you can see what beta 0 means, the mean level for the base level. Beta 1 will be the difference from the class A, whatever it is. So in that case, it's accounting to the class that was left out, and beta 2 will be the difference to the second class, which let's say is